dear students, let us write some definitions. So definitions, these are definitions, students. Definitions of different modes. I am not explaining the mode. Just I told you one statement regarding mode. Mode means the way you carry the power. That much only I explained till now. Later on we will talk of that. So definitions of different modes. We are assuming that wave is traveling in z direction. For wave traveling in z direction, that means, student, these definitions are going to change if wave direction, if wave propagation direction changes. That is why I have mentioned that we are giving the definitions of different modes by assuming wave is traveling in z direction. So for a wave is traveling in x direction, the definitions are going to change actually. We will see that. So for wave traveling in z direction, first one, TEM mode, transverse electromagnetic mode. So TEM mode, right? By definition of transverse electromagnetic, that means TEM, transverse electromagnetic mode. By definition of transverse electromagnetic mode, for wave traveling in z direction, already it is written here. Again you will not be observing this one. That is why I am stressing that this definition is valid only for wave traveling in z direction. Ez is equal to 0 and Hz is equal to 0. If you write in phasor domain, EZS 0, Hz 0 in phasor domain. Because we will do the derivations in phasor domain because they are very simple. Then if you want time domain, you have to multiply EZS with e power j omega t. Then you have to take real part. That already we have discussed that. TEM mode definition. By definition of transverse electromagnetic mode, for wave traveling in z direction, electric field z component, magnetic field z component should not be there. That means TEM mode means in the wave propagation direction, that means z direction, electric field and magnetic field should not be there. Then automatically electric field and magnetic field will be 90 degrees to the wave propagation direction. That means electric field has x and y component and magnetic field has x comma y component. Okay. Similarly, TE mode. TE means transverse. Transverse means 90 degrees. Electric TE mode. TE mode. Okay, students. By definition of TE mode, by definition of TE mode, for wave traveling in z direction, that means transverse electric component. Electric component should be 90 degrees to the wave propagation direction. So electric field z component should not be should be 0, but magnetic field z component, there is no condition, it is not equal to 0. So transverse electric means electric field should be 90 degrees to wave propagation direction, that is z direction. That means electric field components can have x and y components, but it should not have z component. That is the definition of that one. But there is no condition on magnetic field. That means here Hz not equal to 0. Definitely it should be present. Why? Why definitely it should be present? If it is 0, then automatically this becomes TEM mode. That is why. That is why 100% this should be there. If that is 0, then this becomes this mode. That is why it should be there. Now, these are all definitions, students. Third definition, TM, that means transverse magnetic. Transverse magnetic mode. Okay. By definition, of TM mode for wave traveling in z direction, EZS is not 0, but HZS must be 0, because transverse magnetic means a magnetic field should be 90 degrees to the wave propagation direction. That means magnetic field can have X component and Y component, but magnetic field Z component should not be there. Definitely EZS should be present. Once again I am telling, if this becomes 0, again the definition goes to TM mode. Okay, that is why it should be there. Then fourth one, HM, that means hybrid mode. That means it is a combination of TE and TM. So that means here EZS also not 0, HZS also not 0, both are present here. That is the combination, hybrid mode. So by definition of HM mode for wave traveling in z direction, EZS not 0 and HZS also not 0. This is the combination of these two. But anyway, we are going to send the energy in the rectangular waveguide using TE modes only, because that has a lowest cutoff frequency. We will talk of that later on, students. So dear students, now let us talk of TE mode for wave traveling in z direction, by definition of TE mode EZ0 HZ not 0. Transverse electric means EZ0. In phasor domain, suffix S, steady state is added. Now, representation, derivations I am doing, representation of field components, in terms of HZS. Here in TE modes for wave traveling in Z direction, the main component is HZS component. That means that is like mother component that produces other field components. So if you want, I will give the picture now itself. For example, HZS is the main component. Then this component generates EX. If this EX component generates HY, and again if this component generates EY, then this EY component generates HX. Then EX and HY, they are one pair. They together carry the power in Z direction. They carry the power in carry the power in z direction. Carry the power in z direction. Like uniform plane wave only. If you want to carry the power in z direction, then pointing vector direction should be z direction. Then electric field x component, magnetic field y component carry the power in z direction. Similarly, magnetic field y component and electric field y component and magnetic field x component carry the power in the z direction. But in this case, inside Ey or Hx, they say they have opposite sign, so that again pointing vector direction becomes Az only. Anyway, we will discuss this later on. That's what is the important thing I am telling you is that here Hz is the main component that generates electric field components, and according to that magnetic field components are produced. They carry the power in z direction. It is like mother component. It produces these children components. Then these children components carry the power in z direction. Okay. That is why a heading is representation of field components. That means field components means here Ex, Ey, Hx, Hy. But Ez is not Ez is equal to 0. It is not there. Anyway, total how many components are there? Ex, Ey, Ez, but Ez is 0. Next Hx, Hy, Hz. Three components. Among them, main one is Hz. That is like mother component. It produces Ex and Ey, and this Ex produces Hy and Ey produces Hx. They carry the power in z direction. That means now representation of field component means field components means Ex, Ey, Hx, Hy. They are all generated from Hz. Or otherwise, you can say Hz also generates this one. If this is generated, this generates this one. Hz generates Hx also. If Hx is there, then automatically Ey is present. So then they carry the power in z direction. Be careful. Hz cannot carry the power in z direction because pointing vector is equal to E of t cross H of t. If you want power flow unit vector, then electric field unit vector cross magnetic field unit vector. If electric field unit vector has x component, then magnetic field has y component, then power is carried in z component. Then second case, if electric field has a y component, then magnetic field has x component. I told you among them one of them will have plus minus sign, maybe this or this, or otherwise maybe this minus, this is plus. Then so that again power is carried in z direction only, because minus of minus az z direction only. That means you should understand here power is carried by x component of electric field and y component of magnetic field. That is one way. Or otherwise second way is y component of electric field and x component of magnetic field. That is second way. So this is the way power is carried in z direction, but Hz cannot carry the power in z direction. That the role of this is to generate these components, then these components carry the power in z direction. So that is why they also should be there to carry the power. Then if you want these components to be present, this should be there. This is the main component. The role of this is to generate these components. That is why Ex, Ey, Hx, Hy will be a function of Hz here. That type of equations we are going to get now. Before doing derivations, I am talking of the results. So you can see the sequence of equations also. Okay, dear friends, right? Now we will start doing derivations, and whatever you want to do in EM theory, you must start with Maxwell equations. Okay, so this Maxwell equation, del cross E is equal to minus of dou B by dou T, that is B is mu H minus mu dou H by dou T. In phasor domain, del cross Es is equal to, this is a d by dt j omega, so minus of j omega mu into Hs bar. So equation number 1. This is the Maxwell equation. Now what is del cross Es? In rectangular system it is Ax cap, Ay cap, Az cap, dou by dou x, dou by dou y, dou by dou z. Electric field vector in rectangular system is electric field x component, electric field y component, electric field y component, but electric field z component is 0 by definition. So 0, we are talking in phasor domain. So electric field x component in phasor domain, S means electric field y component in phasor domain. That is equal to j omega mu Hs bar. I will expand this Hs bar also. Here Hs bar is equal to Hxs Ax plus Hys Ay plus Hzs Az. That means x component in phasor domain, y component in phasor domain, z component in phasor domain for magnetic field. Now we expand this one. Ax, leave this. Then dou by dou y of 0, dou by dou z of this one, dou Eys divided by dou z, partial differentiation of dou means, then minus of Ay, dou by dou x of this 0, dou by dou z of this. So 0 minus dou by dou z of Exs. Okay? 0 dou by dou z of Exs plus Az, this one you leave, dou by dou x of this one. So dou Eys divided by dou x minus dou by dou y of so dou Exs divided by dou y. This is equal to here minus j omega mu into Hs bar is magnetic field vector in steady state is equal to x component it has, then y component it has, then z component it has. Now we are writing them in phasor domain. Suffix s you have to put steady state. Compare both sides. Compare both sides. Then you got here Ax x component, here also x component. Here minus is there, here minus is there, gone. So you got here dou Eys divided by dou z is equal to j omega mu Hxs. So this is equation number 1. Similarly, if you compare y component, minus into minus plus, okay, then here minus is there, this is y component. So ultimately you have dou Exs divided by dou z is equal to minus of j omega mu Hys. So this is equation number 2, right? Equation number 2. Similarly, if you write the z component here, okay, you can write here. Okay, I will write here. So here there is a dou Ys divided by dou x minus dou Exs divided by dou y is equal to this side minus j omega mu here into Hzs. This is equation number 3. Now there are two Maxwell equations. One is del cross E is equal to minus j omega mu Hs. Another one del cross H is equal to also is there. So del cross H is equal to sigma E plus dou d by dou t, that means epsilon dou E by dou t, that is. So student, for we are taking for lossless dielectric medium, we are solving for lossless dielectric medium. For lossless dielectric medium, sigma 0, so this is 0. So in phasor domain this equation becomes del cross Hs is equal to this epsilon dou j omega, dou by dou t is j omega epsilon es bar. Okay. Now this is equation number 4. You substitute hs bar, that is unit vectors ax cap, ay cap, az cap, dou by dou x, dou by dou y, dou by dou z, x component in phasor domain, magnetic field y component in phasor domain, magnetic field z component in phasor domain, j omega epsilon, but electric field x component in phasor domain, electric field y component in phasor domain, but there is no electric field z component for this mode. Now ax cap, students, I am not writing this directly. I will equate the components this side after writing. Okay, so compare both sides. That means you expand this determinant. Here you will have xyz components. Then this side also xyz components are there. Of course, z is not there. You compare, then you get equations directly. I am writing. So ax cap multiplied with dou by dou y of this one minus dou by dou z of this one, this side, is equal to j omega epsilon exs is there. So now if you compare now, first this is gone, dou hzs divided by dou y minus dou by dou z of hys is equal to j omega epsilon exs. So this is equation number 5. This one here, one more came na. Now similarly, minus ay this side, minus ay is there, this gone. Then dou by dou x of this one minus dou by dou z of this one. So minus I will send this side. So here this no, students. So dou by dou x of this one, dou by dou x of hzs minus dou by dou z of hxs is equal to minus j omega epsilon eys. So this is equation number, you say 6. Then this side z component, na, z component means leave this one, dou by dou x of this one. So dou hys divided by dou x minus dou by dou y of this one, dou by dou y of hxs is equal to, this side there is no z component, it is 0. So ultimately this is 7. Okay, yeah, there is no component here. So az dou by dou x of hys minus dou by dou y of hxs is equal to 0, because electric field z component is 0. Now actually you have seen, students, in uniform plane wave, for wave traveling in z direction, for example any equation for wave traveling in z direction, this has some constant, then e power minus of j beta z, or otherwise I will write e power gamma into e power gamma into e power gamma z. For wave traveling plus z direction means minus gamma z you get. That is uniform plane wave. But in the waveguides, for example, situation is like this: hzs is equal to some constant, that is hz naught constant is there, because in x direction wave wall, in x direction waveguide walls are there, so it should be a function of x. In y direction also waveguide walls are there, it should be a function of y. And e power here minus of for wave traveling in z direction means minus should come, gamma into z should come, but here it is waveguide. In uniform plane wave that is gamma, but in a waveguide it is gamma g, waveguide propagation constant. So This Hz naught is actually initial magnetic field of Z component. It is a function of x and y, some function. Because here there is no function of x, y, because that is unbounded medium. But here waveguide walls are there in x direction, you have seen. Like I told you, m pi by a term comes like that. So here x and y terms come, student, right? For example, if conductor walls are not there in x direction, conductor walls are not there in y direction, then it is not a function of xy. Anyway, you will see the after derivation you will get here cos m pi by xa, sin m pi by xa, cos sin cos, like that terms will come here. You don't worry about that. Now, whenever here the solution of above equations, the solution of above equations are, for example, Hz is equal to Hz0, it is a function of xy e power minus of gamma g into z. Okay. Similarly, Exs is equal to Ex0, it is a function of actually E naught means initial value, Ex naught means initial electric field of x component. That is the meaning. It is a function of xy. Then for wave traveling in z direction, e power minus gamma z should come, but in a waveguide, gamma is renamed as a gamma g, guide propagation constant. So here Eys is equal to Ey0 function of xy e power minus gamma g. Similarly, Hxs is equal to Hx0 xy e power minus gamma g z. Similarly, Hys is equal to Hy0 x comma y e power minus gamma g z. So, all the field quantities initial values are functions of xy. It is they are function of x because of conductor walls in x direction. They are function of y because of conductor walls in y direction. Right. Now, if this is the situation, you differentiate any one of them with respect to z, any one of them. You differentiate with z, partial differentiation with it. For example, Hz divided by dou z. Dou by dou z means partial differentiation with z. That means assume others are constants. Hz naught x comma y e power gamma g z. So students, our partial differentiation with the z means assume z only variable. That z variable is only present here. It is a constant function of x and y. So it comes out Hz naught so x comma y, and ultimately d by digit of this one is e power minus gamma g into z. Then minus gamma g comes. So that is nothing but what is this once again? This is Hzs minus gamma g. So after if you differentiate this with respect to z, you get same thing here, but every time for one differentiation minus gamma g comes. If for two differentiations minus gamma g into minus gamma g square you get, like that it is. So okay, now where is that? You see this equation Eys is a function of e power minus gamma g z. If you differentiate that with respect to z, then you get Eys multiplied with minus gamma g. So here what to write? There is no need to write the story. That equation 1 becomes Eys multiplied with minus gamma g. is equal to j omega mu into h xs. So anyway, you can put it like this, or otherwise you can write EYS is equal to minus j omega mu divided by gamma g into hxs. So this is equation number 8, students, right? Similarly, equation number 2, wherever dou by dou z is there, for all of them it happens. But dou by dou x is there, dou by dou y is there, you should not do that. So dou by dou z is there. So once again equation 2 becomes equation 2 implies now E x s minus gamma g is equal to minus j omega mu into hys. So ultimately from this Exs is equal to minus minus gone. So j omega mu divided by gamma g and hys is there, right? This is equation number 9. Next, equation 3. In this there is no dou by dou z, so nothing will happen to that. Let it be like that. Next one, equation 5. Here dou by dou z is there. That means wherever dou by dou z is there, same term comes, beside that minus gamma g comes. So equation 5 becomes dou hz divided by dou y minus of hys. Here dou by dou z is replaced with minus gamma g, then j omega epsilon E xs. So you send this one this side, or otherwise I will do one more thing. Somewhere Exs is in terms of hys, you see that. So Exs, this one, Exs is present in terms of hys. So let us say this is equation number 10. Put equation 9 in 10, so that you get dou hz divided by dou y is equal to, it goes that side, no? Plus, the plus is there. So hys into gamma g, okay, plus minus, no? This side is there, means plus, this side goes minus. Then j omega epsilon, in place of Exs we are putting this one, that is j omega mu divided by gamma g, and this is hys. So you can pull out hys here. So ultimately hz dou hz divided by dou y is equal to hys, you common, students, then gamma g also denominator, okay, then you get what? Minus gamma g square, j into j square is minus 1, minus omega square mu epsilon divided by gamma g hys. Okay. Now let this let h square is equal to gamma g square plus omega square mu epsilon. So this is also one of the equations, student. So here I will call this also one equation 10, this 11. Now here hys becomes, hys is equal to this side, minus gamma g divided by h square dou hz divided by dou y. So this is equation number 12. One thing happened. Actually, what is the heading? Representation of components. Components means Ex, Ey, Hx, Hy in terms of Hz. So here Hys came in terms of Hz. One thing happened. From now onwards, one by one, all terms are represented in terms of what do you say, Hz. That is the main component. Okay. Similarly, we have used equation. Which equation? Equation 5 we have used now. Now let us use equation number 6. So here also this z is there here. Okay. So equation 6, no? Equation 6 becomes that one. Dou HZS divided by dou x minus HXS minus gamma g minus j omega epsilon EYS. If you see, I will call it as 13. If you see somewhere, definitely EYS will be in terms of HXS. You can see this EYS here. EYS is in terms of HXS. So equation put 8 in 13. Then dou HZS divided by dou x, here plus is there, it goes that side, then minus of hxs gamma g, and here minus j omega epsilon is there. Now EYS from equation 8 is minus j omega mu divided by gamma g and hxs. So dou HZS divided by dou x, here hxs common and hx common, then minus gamma g square is there, denominator I am pulling gamma g, then minus into minus becomes plus, j into j square minus, once again it is omega square mu epsilon and hxs. So this is again minus h square. So ultimately hxs is equal to minus of gamma g divided by, this is taken as h square and minus is there. So dou hz divided by dou x, dear students. So this one is equation number 13 and this is 14. Now you got second term hxs in terms of hz you got. Now hys also you got in terms of hz. Now almost all terms you got, because na hxs you substitute here, then EYS also comes in hz. Similarly, somewhere here this one only HYS is there. You substitute this here HYS in equation 9. Then EXS also you will get in HZ, student. So with that you will complete representation of field components in terms of HZS. Okay. So now put equation 12, this one, in this equation HYS 9, then you get EXS j omega mu gamma g, HYS is this one, minus gamma g divided by h square. So dou hzs divided by dou y. So ultimately you have EXS is equal to this gone. You got minus j omega mu divided by h square and dou hzs divided by dou y. So let us say this some equation 14, 15, right? Similarly, you have substituted equation 12. Now let us substitute equation 14. Put 14 in here hxs here 8. Put 14 in 8. That means then EYS is equal to minus of j omega mu divided by gamma g, and equation number 14 is this one. In place of hxs you have this one. So minus gamma g divided by h square dou hz divided by dou x. Cancel. So EYS is equal to gamma g cancel, minus into minus plus. So j omega mu h square dou hz dou x. This is equation number, let us say 16. Now all the terms you got now. For example, if I write EXS is here. EXS is equal to minus of j omega mu divided by h square dou hz divided by dou y. So this is one equation. Now if I call them, okay, let it be like this. Next, EYS here, this I wrote from equation 15. Okay, then equation 16 I am writing in the sequence, student. EYS is equal to, so j omega mu divided by h square and dou hz divided by dou x. Similarly, equation 14, first I wrote Ex, then Ey, then Hx, Hy. Equation 14, here you have Hx is equal to minus gamma g divided by h square dou hz divided by dou x. Similarly, this is equation 12. Equation 12 implies their hys is there. Hys is equal to minus gamma g divided by h square. So dou hz divided by dou y is there. So here we can see for magnetic field, this H also magnetic and magnetic case, if x is there, here differentiation with x, if y is there, then differentiation with y. And for electric field and magnetic field, if x is there, then y comes, if y is there, then x comes in the differentiation. Okay, so there are four field quantities, Ex, Ey, Hx, Hy. They are represented in terms of Hz. Anyway, Ez is not there, Ez is 0, and Hz is mother component, Hz is there here. So one conclusion is that, students, if Hz is 0 in this case, then Exs, Eys, Hxs, Hy is 0, then total electric field 0, total magnetic field 0. Power flow is not there, so mode doesn't exist, you say. That we will talk of that later on. So this is all about the representation of field quantities called Ex, Ey, Hx, Hy in terms of main component called Hz. Now we have to solve the Hz equation. If we solve Hz equation and substitute here, we get the quantities. After solving the Hz equation, we get some H0 into cos m pi by a into x, cos n pi by b into y, e power minus gamma g into z we get. So if you substitute this, we have to solve this one. If you substitute this one here, then we get Exs, Eys, Hxs, Hys equations for TE mode. Similarly, for TM mode, no, same equations come for TM mode. But anyway, actually for TM mode, no, here you will be representing all quantities in terms of EZS. EZS is main component there. So let us not talk of all the things at a time. Now you have solved for TE mode, you have represented a TE mode components in terms of HZS. Now let us talk of solution of this HZS. Okay. I am putting these terms like this. Let it be like this. Now here solution of solution of HZS. Now we have to write the solution of HZS. Okay. Solution of HZS. For this, what we do again, already you know that wave equation is del square Hs bar is equal to gamma square Hs bar. Now here it is del square, and this is Hxs Ax, H bar is Hys Ay, and Hzs Az is equal to gamma square into Hxs Ax. So Hys Ay and Hzs Az if you take. Now actually our focus is on Hzs. Compare the Z component both sides. So compare Z components both sides. Now what will happen, student? Del square Hzs is equal to gamma square, this side gamma square Hzs. So that is the Z component. I am equating this as equation number 1. This is fresh derivation. Now here this del square is nothing but in rectangular system dou square by dou x square plus dou square by dou y square plus dou square by dou z square. So dou square Hzs divided by dou x square and dou square Hzs divided by dou y square plus dou square Hzs divided by dou z square. You can write here minus gamma square or otherwise gamma square Hzs. So dear students, do you know what is this gamma square for lossless dielectric? So for lossless dielectric, already we know gamma square is equal to minus omega square mu epsilon. So that is nothing but minus omega square mu epsilon H Zs, students. Okay. Now already we know that Hzs is equal to Hz0 function of xy e power minus of gamma g into z. Then if you differentiate this dou square Hzs divided by dou z square, you differentiate this 2 times, then you get same thing but 2 times minus gamma g into minus gamma g. So you get minus gamma g multiplied with minus gamma g, then Hzs. Dear students, I am skipping that. I am not writing this because you differentiate one time, this is same e power minus gamma g z multiplied with minus gamma g. Second time you differentiate, again e power minus gamma g into z multiplied with again minus gamma g, minus into minus plus. So you get gamma g square. Here you can put, so dou square Hzs divided by dou x square plus dou square Hzs divided by dou y square. Here you get this gamma g square Hzs, that is equal to I will get this side. Okay, omega square mu epsilon Hzs. Okay, that is equal to 0. Here somewhere you can see here, can I common both of them, Hzs? So I can write gamma g square, this one. So gamma g square omega square mu epsilon, you can see here. Gamma g square omega square mu epsilon is taken as h square. Okay. So that is h square here. So dou square hz divided by dou x square, dou square hz divided by dou y square plus h square hz is equal to 0. So here students, this hz is equal to hz naught, that means initial value of magnetic field z component is a function of xy. Now this is written as a capital X into capital Y. Capital X means some equation in terms of x. Capital Y means some equation in terms of y. It will be like that one. So hz, this one, or otherwise they write like this. What is this? Equation number 2. Equation number 2. Solution of equation 2 is like this they write. Hz is equal to capital X into capital Y into e power minus gamma g z. That means this one both are same, student, but here together written xy components, but here capital X in place of hz not xy, capital X into capital Y written, e power minus gamma g z written. Capital X where capital X is a function of small x. Capital X is some equation like cos m pi by ax, sin m pi by x, like that it will be. Similarly, y is also some equation, it is a function of small y, right? Let us say this is 3. So where x is where capital X is a function of small x. Similarly, capital Y is a function of small y, right? Now, put equation 3 in equation number 2, then we get dou square xy divided by dou x square plus dou square, of course student, here na e power minus gamma g into z also present, student, here. Okay. Next, dou square by dou y square and xy e power minus gamma g z. Next, plus h square hz. Hz is nothing but once again xy e power minus gamma g z is equal to 0. Students, partial differentiation with x means only you have to differentiate this one. This y e power minus gamma g z comes out. Here partial differentiation with y means you have to differentiate only y equation, but x e power minus gamma g z comes out. So here here also e power minus gamma g z, here also e power minus gamma g z, here also e power minus I will write one more step na. So y e power minus gamma g z, then dou square x capital X divided by dou x square, and partial differentiation with y means y only variable capital X into e power minus gamma z gamma g into z, then dou square y by dou y square, then ultimately h square xy e power minus gamma g z is equal to 0. So here e power minus gamma g z here also and here also common. Okay. Now this is y into, it is written as x double dash. Capital X is a function double differentiated with respect to x. Similarly, this one na x into this is written as a y double dash plus h square xy is equal to 0. In all of them, e power minus gamma g z common, it goes outside, that becomes 0. So you divide this equation, divide above equation with xy, then it becomes y cancel, so x dash by x plus divide with xy, xx cancel, so x double dash no, y double dash by y. Here xy you common, so xy cancel. Now x double dash divided by capital X plus h square is equal to minus of y double dash by y. It is taken as some constant. It is taken as some constant square. Okay, because if you double for one differentiation you get one constant, for a second differentiation you get second constant, so that is why a is constant. Constant square is taken here like that. So let us say this is equation number 3, 4. Okay, now let us select this one. If you select this one, minus y double dash divided by y is equal to a square, that implies minus y double dash is equal to a square y, that ultimately, what is this y double dash? You can see here, y double dash, no students, this one y double dash for example. So here y double dash is dou square y divided by dou y square, and if it goes this side, plus a square y we get, okay, is equal to 0. So in the differentiations now it is written as d square capital Y and a square y is equal to 0. So d square plus a square into y is equal to 0, where capital D is equal to dou by dou y. Dou by dou y. This is differentiation terminology. Now roots are d square plus a square 0. That means d square is minus a square. So d is j square. This is minus 1 is j square. So root of j is plus or minus j into a. Now the solution is for this one, or otherwise for this equation, numerator quantity, this one, that is y, is equal to some constant. I am writing c1 dash, that constant, exponential first root. You can take plus a ja or minus ja, any one of them you can take, no problem. So plus ja first root ja. Here na roots are what do you say, plus ja one root and minus ja second root. Okay, two roots are there. So numerator variable, that is y, is equal to, for first root c1 constant 1, I have taken that as a c1 dash. Then exponential first root plus ja into denominator variable, that is independent variable actually, small y, that is small y, plus second constant, I am calling it as a c2 dash, exponential second root is minus ja, and here independent variable is y, like this. Now y is equal to c1 dash, this is cos ay, okay, next plus j into c1 dash into sin ay, because this is cos ay plus j sin ay. I am multiplying with c1 dash, so this one, right, plus this is a cos ay minus j sin ay. So c2 dash into cos ay, then minus j into c2 dash into sin of ay, small y students, small y. Now y is equal to c1 dash plus c2 dash into cos ay. Next, j into c1 dash minus c2 dash is equal to sin ay. Now again this is taken as some constant called c1. So c1 into cos ay plus this total is taken as some constant 2 and sin ay. This is equation number, let us say, 5. So here students, anyway among them c2 becomes 0. c2 means this one student, including total one, is called c2. Okay, c1 I am calling this as a constant 1 and I am calling this as a total as a constant 2. So anyway constant 2, one of them becomes 0 from the boundary conditions we will see. Okay, similarly if you take from equation 4, equation 4 implies you take that x double dash divided by capital X plus h square all together is taken as a one constant. Okay, that is taken as a minus b square. Okay, now yes, you have to do like this student. Actually a square, na, this is one time we have taken this is equal to a square, second time total term is taken as a square. Now that is x double dash by x capital X double dash by capital X plus h square is equal to a square. Okay, now let us send this x double dash by x is equal to a square minus h square, and x double dash by x is equal to minus of I can write this like this, minus of h square minus a square. It is correct, na? You see here minus h square is there, minus into minus plus, plus a square is there. Now x double dash by x is taken as this together taken as b square here. So this is equation, what do you say? Otherwise actually this is correct, but I want to tell you relation between a square, b square, h square. I will tell you. So let us say, let it be like this, where minus b square is equal to minus of h square minus a square. That means minus minus gone. So a square plus b square, a square plus b square is equal to h square. This is also one equation. What is this? Equation number 6. So here h square is there, no student? A square plus b square. That capital A becomes m pi by a, capital B becomes n pi by b, and n pi by a whole square plus n pi by b whole square. So this h square equation, and here h square was there, it is removed. So h square is equal to gamma g square omega square mu epsilon also was there. So that h square is that one here, this h square you got in terms of capital A and B. There h square was gamma g square omega square mu epsilon also was there. Now anyway, once again take this equation. So x double dash divided by capital X is equal to minus b square. So it is written similar to this, student. Again same story, this one. Solution directly we can write. So anyway, I will write 1 or 2 steps. This is nothing but dou square capital X by, you send this side. First I will do like this. X double dash is equal to minus b, this one, and if it b square na, plus b square capital X is equal to 0. What is this? This is nothing but dou square capital X divided by dou x square plus b square x is equal to 0. So if you take dou by dou x as a d, and this is d square x plus b square x is equal to 0, where capital D is dou by dou x actually. So this one, d square plus b square into capital X is equal to 0. Student, we'll do one thing. Why to waste time? We will call this as equation 4 dash, student. 4 dash. Okay. Now we will call this equation as a 7. So equation 4 dash and 7 are similar. Similar, na? D square plus b square into x is equal to, where is that equation for this one? D square plus a square into y is equal to 0. So solution will be similar. So that's why now capital X is equal to, here some constant, we will call that constant as C3 now, because C1 and C2 are used. C3 cos, here A was there, that is why A came. But with respect to differentiation with respect to small y, here differentiation with respect to this one, small x. So that is why you get b small x plus some constant C4 here, na? In place of C2 I am putting C4 and sine capital B x. So this is equation number 8. Actually, na, there C1, C2 constants, here C3, C4 constants. Then cos term, here sine term, in cos, sine. Then where A was the constant name and here B is the constant name. Then variable was, differentiation variable was small y, here differentiation variable is small x. So now ultimately that you can see here, Hzs is x into y into e power minus gamma g z. But no need to bother about this one. So here only magnitude, if you take Hzs is equal to x into y. So that x you got here, that y is here. Y is there. Now so ultimately for that number is going to put equation 5 comma 8 in equation number, this equation is 3. Okay, in 3 Hzs is equal to, x is this one, C3 cos bx plus C4 sin bx, and similarly this one C1 cos ay, then C2 sin ay, students, into e power minus j beta z is there, right? Into e power minus e power minus gamma gz, because if you substitute gamma g is equal to j beta g, then e power minus j beta g z. Anyway, this is the equation. Now you see this one here, EXS, EYS. Electric field tangential component is 0 near the conductor surface. Do you remember we have studied this in boundary conditions? I have taken this is medium to conductor, then total electric field is equal to 0 in the conductor. This has electric field tangential component and this has electric field normal component, then tangential also 0, normal also 0, and here this is medium 1, and here this first boundary condition is ET1 is equal to ET2 is equal to ET1, otherwise ET1 is equal to ET2. Substitute ET2 0 here and ET1 0. I told you if this is the conductor, on the conductor surface the component which touches the conductor, that is called tangential component. This side is medium 1, so electric field tangential component is 0 in medium 1. We have studied, that's what I have written, E tangential 0 near the conductor surface. From that I am telling you EXS here, EXS, that becomes electric field tangential component 0 at, then here also electric field Y component, that also becomes tangential component, so EYS that also 0 at. I will show you that one. So I am putting these things as it is. Previously derivation done, na? Representation of field quantities Ex, Ey, Hx, Hy in terms of Zs. Now we are about to get the solution of Hz. You substitute that here, then derivation is done. Now I am showing, just a moment, I will change the pen. So students, you see this one, this is the x direction I have taken and this one is y direction I have taken. This x direction total width is A, this is called x is equal to 0 wall and this is called x is equal to A wall, and this is called y is equal to 0 because this is y direction, and this is called y is equal to 0 and this is called y is equal to B, right? Now you see this EXS. Tell me what is the meaning of EXS? That means here EXS. EXS means electric field component in x direction. Then electric, this is x axis, so that electric field component is like this, student, like this, x direction it is. EXS means electric field component in x direction. I told you this we have taken as x axis. If you want, I will draw the diagram here. This one, okay, this is x axis we have taken, this is y axis we have taken, and this is the waveguide. Okay, now EXS means that is in x direction. Now any component is in x direction, that is tangential. Tangential means parallel to this surface. Which surface? Conductor surface. At which height is that? At y is equal to b height. So at y is equal to b, comma, here also it is tangential. Tangential means parallel. At y is equal to 0 also it is tangential. So at y is equal to 0. So that electric field x component is tangential to, this is y is equal to 0 conductor surface, this is y is equal to b conductor surface. For both conductor surface, EXS is tangential component, EXS is tangential component. Now we know tangential component of electric field is 0 near the conductor surface. So that is why EXS is 0 at y is equal to 0, comma, y is equal to b. Similarly, this EYS component EYS means electric field Y component is in Y direction. It is in Y direction. Y direction means like this. So this component is parallel to this surface. And what is that? X is equal to 0. And also this component like this, like this, like this is parallel to this surface also. That is X is equal to A surface. So at X is equal to 0 surface, this one, at X is equal to 0 conductor surface, and at X is equal to A conductor surface, this EYS is a tangential component. Now electric field tangential component is 0. So at X is equal to 0, comma X is equal to A, dear students. What is happening, you know? 1, 2, 3, 4. At 4 locations, you know the initial values. And with 4 locations, you will get values of 4 constants. You can see here 1, 2, 3, 4 constants. Then you find that 4 constants, then solution is over. So to get 4 constants, you need 4 boundary conditions. They are called boundary conditions actually. Okay. Now let us take shall I use there? Okay. Here I am doing derivation. Dear students, here I have done one equation. Here itself I will do so that you will be comfortable. EXS is equal to 0 at Y is equal to 0. That means this is EXS. So EXS 0 at Y is equal to 0. At Y is equal to 0. What is EXS? This one. That means minus of j omega mu divided by h square, then dou by dou y of hz, this one. Dou by dou y of hz, this one, is equal to 0 at y is equal to 0. Now anyway, this goes this side, that becomes 0. Now you take this hz and differentiate that with respect to y. That means this will be as it is. You have to differentiate only with respect to y, and nothing to do with this also. So you differentiate now C3 cos bx, C4 sin bx multiplied with, you differentiate this one with respect to y. That means you get C1 d by dy of this one cos is minus sin ay multiplied with a plus, then differentiate this C2 d by dy of sin is cos ay into a. This is the term, and you have to substitute y is equal to 0. That means y is 0, then it is equal to 0. At y is equal to 0, that value is 0. Now you substitute y 0, no student. This sin ay, sin 0, 0, this gone, and ultimately you get C3 cos student. This one comes here as it is, but anyway, if you send e power minus gamma gz here, it will send that side, it becomes 0. No need to write that one. So this is C4 sin bx, and here this is 0, and C2 into cos of ay into a. Cos y is y value, how much you have put? Y0 means cos 0 is 1. So a is equal to 0 you got. Here don't touch this term. A is constant, that constant cannot become 0. That means this cannot become 0. So that implies C2 is equal to 0. That is the conclusion, that C2 is equal to 0 because this is constant. Now if you substitute C2 0 here, you got a HZS equation like this. Oh, okay, later on I will put. Okay, HZS has become like this: C3 cos Bx plus C4 sin Bx. Okay, and C2 0 you have put, then C1 into cos of Ay, cos of Ay into e power minus gamma g into z. Okay. Similarly, here EYS is 0 at x equal to 0. That means EYS is it means this one. So this is equal to 0 at x is equal to 0. From that we will conclude C4 also 0. Then again we will substitute Ex is 0 at y is equal to b. We get one constant, and again Eys is equal to 0 at x is equal to a. We will get another constant. Then derivation will be completed actually. So here I am continuing that. So Eys is equal to j omega mu. So dou hs dou hz dou x. So j omega mu h square dou hz dou x, that is Eys. Okay, dou hz by dou x. Now Eys is equal to 0 at, you can see there, at x is equal to 0. Now from this j omega mu divided by h square and dou by dou x of hz. Now I wrote fresh one with respect to x you have to do. So that is C3, right, cos bx plus C4 sin bx, then multiplied with C1 cos ay. So C1 cos ay. Of course, no need to take that minus e power minus gamma gz, that becomes 0, student. So this is equal to, at x equal to 0, this becomes 0. So this is actually Eys, that becomes 0 when you substitute x equal to 0. So that means this also goes that side, that is 0, and ultimately this is like this. So C3 into d by dx of this is minus sin bx and b, next plus C4 divided sin d by dx of sin is cos of bx into b, C1 cos ay is equal to 0 at x equal to 0. You substitute x0 here, this is gone. Then C4 cos 0 1, then into b, then C1 cos of ay is equal to 0 you want. Actually cos ay, no student, this can never become 0 because y is variable. So at different y values, different values are there, it cannot become. So this cannot, these two terms, no, already they are also decided. C1 is not 0, C2 has become 0. So this is not 0. This is some constant, this is also not 0. That implies C4 should be 0. So C4 should be 0. Now that equation HZS, after substituting C4 0, HZS becomes C3 cos bx, then C1 cos ay. Okay, e power minus of gamma g z. Now once again, E electric field x component is equal to 0 at, you can see here students, I wrote here electric field x component is 0 at y is equal to b. Here electric field x component is this one, minus j omega mu h square. So minus j omega mu h square dou hz dou y, that is exs at y is equal to b is equal to 0, right? So here you get automatically this goes this side, it is gone. Then dou by dou y of hz, this is hz. So ultimately this is hz, differentiate with y and you get actually c1 c3, differentiate with y means only this one, cos bx, then minus sign what do you say, okay, minus sign ay into a, right, this one d by dy of cos ay, minus sin ay into a. Then of course if you want you can write e power minus gamma gz, that also becomes 0. At student, at y is equal to, that also you have to substitute, at y is equal to b. Now c1 c3 not 0, this variable is there, if variable is there this also cannot become 0, this is constant, cannot become 0. So from this this not equal to 0 and this is also not equal to 0, y is equal to b is equal to 0. So this is constant actually, that cannot be 0. Ultimately from this sin ay is equal to in place of y you have to put b, student. So sin a into b is equal to 0 actually. Now that implies when sin becomes 0, this theta, you say theta is equal to n pi, where n is equal to 0, 1, 2, dash 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 integer. So n 0, sin 0 0, then n is equal to 1, then this becomes a pi. So sin pi is 0, like that. Now from this capital A is equal to what do you say, n pi by b you got, okay. Now shall we call this as some equation? Which equation number going on? Some equation number 7, like 8 you have to put. Anyway, you put it as a 9. Similarly, this one, EYS is equal to 0 at x is equal to a, students. That EYS means this one. So j omega mu divided by h square, then dou by dou x of hz, this is the hz. So dou by dou x of hz, this one, dou by dou x of, that means c3 minus sin b x into b, next c1 cos of ay and e power minus gamma gz at x is equal to a is 0. Now here I put this also, this also. Now I was telling you every time हर बार बोल रहे थे ये वाला है, इस साइड जगह का 0 हो जाएगा बोल रहे थे, कोई बात नहीं है. So you have to substitute xa, student, xa you substitute, then c3 minus sin small capital B into small a, next b is there, what do you say, c1 I will write here, the c1 is there, cos of a y, this went that side, gone, so it has become 0 because I have substituted x equal to a. Now already I told you here variable is there, na students. Variable is there means it cannot become 0. And this is constant, so it cannot become 0. And already these two were decided they are not 0. So ultimately sign in this sign BA becomes 0. That implies B into small a is equal to some integer called m into pi, where m is equal to 0, 1, 2, 3, then dash dash dash. So m0 you put here, you put ba is equal to 0, sin 0 0. M is equal to 1, then pi you get, then sin pi 0, like that. So this is valid. So ultimately capital B is equal to m pi by a you get. So this is equation number 10. So what is the final solution? You got, students? Final solution is HZS is equal to C1 C3 here, na? C1 C3, then cos of capital B is m pi by a into small x, then cos of capital A is n pi by b into y, and ultimately e power minus gamma g z. So this is the final equation. Now this one is called as HZS, is this one is called as simply some h naught cos of m pi by this one, na, h naught some constant, because this doesn't have unity. E means 2.71. Cos, sin, they are ratios. They don't have units. Then this term product should have unit of magnetic field h naught into cos m pi by a x cos n pi by b y e power minus gamma g z. So this is the solution of the main component, that is HZS. Okay. Now if you substitute this HZS in these equations, HZS, now you get the solution of them. So for example, EXS is equal to minus of j omega mu divided by h square and dou by dou y of HZS. This is dou by dou y of HZS. With respect to y, you have to differentiate. So anyway, I will write dou by dou y of HZS. Okay. Now EXS is equal to minus j omega mu h square, and dou by dou y means you get here h naught. Same with respect to y you have to do. So with respect to y you do not, student, here n pi by b you get. So d by d pi of cos is minus, you get minus n pi by b you get. Then this is same cos of m pi by a into x. Student, what I was telling, d by dy of this one means of course dou by dou y, partial differentiation y, only you have to differentiate this one. So here minus sin n pi by b into y and n pi by b. So that means minus sin into n pi by b. So minus n pi by b I wrote here. Then e power minus gamma g z. So ultimately minus into minus become plus, student. So this one minus into minus become plus. So this is the equation. Now this can be written as I told you, cos, sin, they are ratios, no units. E means 2.71, that doesn't have unit. Even here na gamma is unit is 1 by meter, z is meter, 1 by meter into meter, no unit. So it should have unit of electric field, that too, that is the initial value. So electric field initial value means not for x component. You can write like this. Okay, different books give different names. This is the electric field value, not means initial value for x component, because for every electric field you write E naught, it will be confused. That is for x component. Into, so cos of m pi by a into x, so sin of n pi by b into y e power minus gamma g into z. Similarly, this is all about ex. Similarly, eys you take, so eys if you take, that is equal to, directly I will write, student, j omega mu, this one, divided by h square, then dou h dash divided by dou x, you have to partial differentiate with this x, then you will get minus of m pi by a, because this is minus sign m pi by a into x into m pi by a, so minus m pi by a and this side, ultimately this is sine, then this is cos n pi by b into y e power minus gamma g z. Similarly, you take hxs, okay, hxs. So hxs is equal to minus gamma g divided by h square, and you have to differentiate with respect to x, this one, you get, are we missing h naught here? H naught is taken, h naught also is there, no student? Right. So multiplied with h naught, then differentiate with x, then minus m pi by a and sine m pi by ax, then cos of n pi by by e power minus gamma g z. So similarly, last term hys, na, hys. So that hys is equal to minus gamma g by h square, and you have to differentiate hz with respect to y. So h naught, this is as it is, cos of m pi by a into x, differentiate with y, then minus sine, you get n pi by b into y, so n pi by b and e power minus gamma g z. I was telling you every time minus n pi by b, you write here, because that is constant, minus n pi by b. So this minus, this is there. Now minus into minus becomes plus. Here also minus into minus becomes plus. Here minus is there. Okay. And in this term plus is there. Okay, let it be like that. Now these are the equations. The conclusion is that I was telling you, wave is traveling in z direction. Wave is traveling in z direction. That means power flow also should be in z direction. Electric field direction cross this one. Power flow also should be in what do you say, z direction. Now let us see. Here electric field, okay, this one, electric field x component, can you see here anywhere minus is there? No. That means electric field x component is ax cap, positive sign is there. Then magnetic field y component, electric field x component and magnetic field y component, like that. Somewhere something is it seems missing. Here also you should get plus, student, so that electric field, no, I am electric field x component, magnetic field y component, I am telling, na, this one. So this has a positive sign, definitely it also should have positive sign, so that here ay cap, then ax cross ay is equal to az, so power flow is in az direction, correct. So this is also having electric field x component, magnetic field y component, both have same sign, so that they carry the power in z direction. For example, if this has minus sign, that also should have minus sign there, definitely. Now here if you see electric field, if you take this component, this one, electric field y component, then that generates magnetic field x component, but both will have opposite sign definitely. So for example, you see here minus is there, that means electric field has a minus ay component, cross magnetic field has a plus is there here, plus ax component. So minus of ay cross az minus az. So ultimately power goes in once again z direction, dear students. So I am briefing this one. What is happening here? I told you at the beginning before starting the derivation that HZS is the mother component for TE mode. Mother component means main component. So this is the mother component for TE mode. Then this mother component generates EXS, for example. Then this EXS generates HYS. Then EXS and HYS together, that is one pair, that is one jodi, that jodi or otherwise that pair carries the power in z direction because wave is traveling in z direction. HZS, you can say like this also, HZS generates HYS, that HYS generates EXS, then both carry the power in, what do you say, z direction. Second statement, this HZS generates EYS, then that EYS generates HXS. So EYS and HXS, they have opposite sign. Again, they carry the power in Z direction. Otherwise, you can say HZS generates HYS. This HYS generates EYS. Both carry power in Z direction. That means I want to say, if EYS is there, automatically HXS is there. Both are interchanging. Then electric field Y component divided by magnetic field X component, they are linked with impedance of the waveguide. I will show you that also. Impedance, electric field by magnetic field is linked with impedance. Now here impedance is waveguide impedance, actually that one. Okay, so this is the mother component now that generates this children component. This children component carry the power in z direction. This cannot carry the power in z direction because you are seeing here, to carry the power in z direction, electric field x component, magnetic field y component. Here to carry the power in z direction, electric field y component and magnetic field x component, they should have opposite sign, so that again power is carried in plus z direction, dear students. So here if you see carefully, this one here, from here also you can see, here also you can see, students, that what discussion, impedance of the waveguide, impedance of the guide in TE mode is equal to, impedance is defined as total electric field magnitude by total magnetic field magnitude, like this. So if this total electric field vector has EXS AX plus EYS AY, then modulus of electric field is root of EXS square plus EY square. This is vector definition. Similarly, magnetic field, total magnetic field is equal to HXS AX plus HYS AY, then total magnetic field magnitude is HXS square plus HYS square. Then some students may ask doubt, sir, why are you not writing HZS? And I told you that HZS is only mother component. These components only, electric field XY and magnetic field XY components only carry the power. They start interchanging each other. That interchanging happens because of eta. So eta gives a relation between E and H. So whichever component generate each other. For example, electric field X component generate magnetic field Y component. Electric field Y component generate magnetic field X component. They only interchange the energies or powers through the intrinsic impedance. So now from this, if you write here, modulus of electric field is root of EXS square plus EYS square divided by, this one is HXS square plus HYS square. Now this eta G for TE mode is equal to, eta means intrinsic impedance, G means guide, wave guide. For TE mode discussion is going on. EXS is this one, and whole square of this, EXS means this one, J omega mu divided by h square dou hzs dou y whole square. EYS means this one, j omega mu by h square, and then dou hzs divided by dou x whole square under root. Now divide with eta g, simply I will write, student. Now hx is this one, gamma g divided by h square and dou hzs dou x square plus, where is that component, this one, gamma g divided by h square dou hzs divided by dou y square root j omega mu by h square whole square. J omega mu by h square whole square is common numerator, it comes out. I will write here. Now eta g is equal to, in numerator na, j omega mu by h square whole square, inside root comes out, this much remaining. Then root of dou hzs divided by dou y whole square plus dou hzs divided by dou x whole square divided by eta g. Now here bottom side gamma g by h square comes out, once again dou hzs divided by dou x square plus dou hzs divided by dou y square is the common. This gone, but ultimately you get h square gone, so you get j omega mu divided by gamma g. You know, if we have seen, if f greater than fc, no, then that gamma g was purely imaginary j beta g, so j omega mu divided by j beta g, j cancel, and eta g is equal to omega mu divided by beta g is anyway I have written there, in case 3 I have written, student, discussing root of 1 minus fc by f whole square and omega cancel, that implies eta g is equal to here na, root mu by epsilon root of 1 minus fc by f whole square you got. So I wanted to tell you that electric field and magnetic field ratio, eta g definition is electric field by magnetic field, you got this one. So electric field is changed to magnetic field is changed to electric field because of impedance, you got this formula. Now I am not putting this in the box. So my dear students, till now what I have explained is that for the TE mode, the main component is HZS. That HZS generates other components. So they carry the power, other components. They carry the power. Later on we will see, no, student. Electric field Y component and magnetic field X component carry power in TE10 mode. We will see that TE10 mode. And TE01 mode, this electric field X component and magnetic field Y component carry the power. In TE11 mode, this also carries, this pair also carries power little bit, this pair also carries power little bit. So we will see that. Anyway, student, this till now you should not learn anything at all, because this is all derivation part, nothing is there. You should not study. This is the way BTech teachers teach. So actually every year I was teaching without derivation. I was writing these equations simply with some technique. But anyway, this time I thought of deriving this one. After derivation, I gave this equation. Some of you might be very happy by seeing this. So anyway, we can write them without derivation also. Now time is not there, no need to discuss that, because nobody will ask you these equations for competitive exams. That is the fact. Because every faculty, GATE faculty teaches them, they don't know why they teach. I am telling you, nobody will ask these things. Okay? Don't worry about them, forget about them. Now, after this, we are going to start the discussion by putting TE mode. There, we will write these equations by taking like this, dear students. Here, what do you say? This is H naught, na? We will take this as a E0x. We will take this as a E0y. So similarly, we will take this as a H0x. We will take this as a H0y, student. By taking them, we will write the equations. After that, I will be telling you sequence. We have to remember the equations like Fc, beta g, phase velocity, guide wavelength, intrinsic impedance, which I have derived here. Okay. Till now, I did not put any equation in the box. That means you also should not put any equation in the box. कुछ बच्चे लोग ये डेरिवेशन करने के समय में ये आया है, वो आदत से हाँ डब्बा में रखो, ऐसा रख देता है. ऐसा मत रखो. मैं नहीं रखा है इधर. Because strictly follow my instructions. If I am putting anything in the box means that is important. You have to learn for the examination. Now till now I did not put any equation in the box. And that means don't bother about them. You have seen for maybe 1 or 2 hours. You got the feeling, good feeling. That is feeling is more than enough, and no need to study anything. Now I will be putting the heading TEMN mode. Then after writing these equations, what are required, I will write. We will go ahead. Actually, for EC students, this waveguide topic is very, very, very easy in exam point of view. Every time you see any examiner student, all the questions are based on formulas. Those formulas are simply FC formula, beta G formula, guide phase velocity formula, wavelength formula, impedance formula, and at maximum power carried by the rectangular waveguide formula. Maximum, these are the formulas which you have to remember. Not total this chapter, not more than 20 formulas. Every time you get 2 marks. So it is very simple chapter. You should know what to study. I told you this headache you should not study. If you start studying everything, you will not read what is required. We will start again freshly TE mode discussion.